All right, first test. Does the mic work? We good? Okay. Hey, good afternoon, everybody. My name is Brigadier General Beth Bain. I'm the Chief of Transportation and Commandant of the U.S. Army Transportation School, and I've got the privilege this afternoon of serving as the moderator for this panel. I'm joined by three experts on the topic of driving innovation in transportation, and so I'll quickly introduce each of them, and then I'll let them talk about their respective organizations. We'll do some questions up here, and then look forward to taking questions from the audience. So I'll start here on my left, Colonel Ken Bernier. Ken is the military deputy for our ground vehicle system. Ground Vehicle Systems Center, and that's your first acronym for today. So GVSC, Ground Vehicle Systems Center, and Ken will explain exactly what they do. Mr. Earl Newsom, Mr. Newsom is the Vice President and Chief Information Officer for Cummins. And then Mr. J.D. Johnson, who's the Vice President of Business Development for GM Defense. So again, glad you're all here. Look forward to the discussion, and we'll start, Ken, with you.
Ma'am, thank you. Thank you for coming late on a Friday. I know there's probably something better to do or not, but I appreciate it. So I am from the Combat Capabilities Development Center, or the Ground Vehicle Systems Center, and I won't say the acronyms. But what I would say is that if you think about what does the Army do for innovation in the ground, just think of us at DevCom. Because currently, annually, we're appropriated, or Congress gives us money for about $1 billion. So that's $1 billion annually to innovate. And I say that to my kids, and they don't know what that means, which is totally okay. But what we do is we try to solve hard problems. And I use these two examples with my kids, and they get it, and maybe you will too. The first is if you take your smartphone and you throw it in the freezer, and you take it out in the morning, what's the probability it's going to work? Second is you take it and you'll leave it on the pavement outside, what's the probability it's going to work? And for DOD and in the Army, that's a wicked problem. That's a really hard one that we're trying to solve. Another great problem is as you look to electric vehicles and hybrid electric, one of the things that private industry is going to discontinue is AM radio. Not that AM radio is going away, but it's a hard problem to deal with the electrical interface and interference. Well, to us, that's a wicked problem, and that's a really tough problem. So those are problems that when we talk a real high level, that's what we're trying to solve. And then our superpower to do that is with partnership. We take that money and we partner both with these fine gentlemen, other small businesses, other people that have good ideas. And we're doing that every day, and really to try to solve those really hard problems. And when it comes to transportation, there's a couple areas that we're really focused on. And the first is reduction in logistics burden. And I think back to, this is a really old problem. Like ever since Roman chariots, you're trying to figure out how to make the horse go further with less food. So you have a problem there you got to solve. Well, that's no different than what we're trying to do here, which is how do I use the capabilities we have, gasoline, diesel, whatever you want to call it, and go further. And that's one of our biggest problems that we're trying to solve every day. And then once we get there and keep sustaining it over time with less. So we're trying to solve that problem. And it's a hard problem. It's one of our wicked hard problems. You combine that with another one, a great area is about additive manufacturing. Our current process is something breaks, and then we ship it. Planes, trains, and automobiles to the point of need. Well, we should be able to print that. Right? Capabilities, you should be able to print a good part, and you're seeing that. But there's a lot of obstacles to get over with materials and stuff like that, and those are all things that we're trying to make completely transparent to the soldier and be able to give that to them. The second area that we're really focused on is in maintaining and sustaining the current fleet. We have a significant problem. If you're not aware, the DOD has a very large fleet of vehicles. The next part is most of them are designed in the 50s and 60s, some in the 70s and 80s. Well, the problem with that is that most of all the parts in that are obsolete. And that private industry it is not in their best interest to continue to make it. So one of the things that we focus on is attacking that, replacing it with a modern solution. And we do that through partnerships. And then when we can, we actually look for opportunities to make things better. And I'll give you a great example. You know, if you were in this last one, they talked about stamps, mobile power grids. But what if we could do that on the vehicle? And that's one of the areas we've looked at, which is take any vehicle and then take the generator that's on it right now, or alternator, which creates the power, and move it to a different place in the engine, where that every engine is a generator. Every one of them could be able to produce power at the point of need. So just flip back. California, a lot of snow the last few weeks, great. What if the National Guard rolled up and their truck that they brought with them that could just plug in and turn back on the hospital, essential services, and anything else? And it provides that opportunity as we continue to attack our fleet and look at it. And so if you take nothing, and I look forward to your questions, we're a $1 billion innovator every year. We're trying to solve the hardest problems out there, and we do that through partnership. We partner with industry, we partner with small business, we even partner with folks who do nothing other than help people who have nothing to do with DOD partner with DOD, so we can make those connections. So thank you, I look forward to your questions.
All right, thanks again.
Thanks for that. And I will also apologize because I know we're between you and cocktails. So, but I also want to say that as Cummins' perspective, and this is very interesting, is that you know, as the Colonel talked about, really solving presenting wicked tough problems. I love that designation because that's what Cummins is. We're an engine manufacturing company, an industrial company that loves to solve wicked tough problems, and we're a leader, kind of in solving some of these problems. And Cummins has one of those wicked tough problems that we're very proud of is, trying to work on sustainability and creating a destination zero. And we've committed through all of our products to reduce emissions and improve sustainability and provide clean energy solutions and power solutions in the industry. Our destination zero strategy gets us there, and we're focused on achieving that by 2050. We think our destination zero strategy will benefit the soldier by really focusing on mobility, and thinking about both existing and future solutions that we're going to do. We're going to reduce the logistics and manpower required to transport fuel, like you kind of talked about there, providing digital solutions and working with partners to help us create those digital solutions that provide higher levels of reliability and maintainability. We really want to focus on doing this at scale, right? And so that's one of the things that Cummins brings is worldwide manufacturing scale and capabilities to really bring our commercial solutions to the combat environment, right? And we believe if we do that, we can actually help the soldier be more effective. I'm a West Pointer and a former soldier and a veteran. And so I'm proud to be a part of Cummins and proud of Cummins' reputation of supporting the military. Cummins is, since 2015, we've partnered with GVSC. I'll use the acronym.
Yeah, there we go.
Since you spelled it out for them.
Once we've spelled it out once, we can use it.
I
That's
can use
the rule.
it from there, yeah.
That's right.
And we've worked with smaller organizations like Ashotes Power, which is a startup. It's a 20-year-old startup, but it's worked with us to create a brand new engine platform for motor vehicles in the military, and we call it ACE, which is our Advanced Combat Engine, and it's been a dramatic improvement in capabilities, a 13% improvement in fuel efficiency, a 50% improvement in power density, and then it also gives us the platform for hybridization of the combat vehicle. And so we're very, very proud of that work and very, very proud of our partnership and being part of that ability to bring those innovative dollars to bear. And I also talk about ACE. I talk about ACE in another way, and I talk about ACE being one of the trends of the industry. And the trends of the industry, and for power industry, it'll be ACE as well, and it'll be automated, it'll be connected, it'll be very energy diverse, right? And so, we know that automation is going to drive us, and I've heard, we've talked about, the previous one about AI and those kinds of things, and intelligence and how you consume power and how power is delivered to you. That'll be very automated. In order to achieve that level of automation, it'll be very, very connected, billions and billions of connected things working together to help solve some of these power distribution and consumption problems. But it'll also be very energy diverse. So from fossil-based fuels to non-fossil-based fuels to fuel cells and battery electric, and dare I say, dilithium crystals. That's why I'm wearing a Star Trek shirt. And so I think energy diversity will be the way of the game, the way of the future. As we think about power density challenges and those kinds of things, we know that we're going to need to have a diverse energy future in order to meet the energy needs of the military. And so we're working on that. And we're working on continuing to advance our ICE engines to really reduce emissions and support renewable fuels, such as JP8, hybrid drivetrains, fuel cells, as I mentioned, batteries and battery technology for energy storage for extreme temperatures. I will also say that as we think about the things that we're doing in our engine space and trying to reduce greenhouse gases, we're really working on reducing fuel consumption. So making better engines and better power sources to really reduce the amount of fuel that's needed to serve the soldier on the combat field. We want to create hybrid kinds of capabilities so that you can go in silent mode and electrification inside the vehicle. So these hybrid strategies will have electrified powertrains that will support either quiet operations, quiet movement, quiet operations or still operations that can support the electronics on board without having the engine run. So all of these things are things that Cummins is doing. We're working on, outboard energy storage, those kinds of things to power additional equipment. The microcell or microgrid kinds of concepts. So you can actually just think of a Ford F-50, plugging in and running a campsite. You can do the same thing now with the military application and have that vehicle there to power the things that the soldiers need on the battlefield. And so we're very, very proud about that. And so it's often said the best way to predict the future is to create it, right? And so Cummins, we're creating that future where power and energy diversity is the way of the future. And I'm just exceptionally proud to be part of this panel and part of talking about how we're going to create this amazing future together.
Great, thank you. Mr. Johnson?
Well, you had me all the way up to the point you said Ford 150. I'm not 100% sure I know what that is, but it's another acronym we have to work our way through. I'm sure. Right. I'd like to appreciate everybody being here. I look forward to your questions and the dialogue both during this panel and at the reception afterwards. We find ourselves at an inflection point. We talk about ground transportation. Probably it's been since the 30s, 40s that you've seen things come together in the way they're coming together right now, where you've got different kinds of propulsion, or at least making use of that propulsion differently. You've got the way we share information, move data differently than we have before. Back at that time, they had airplanes for a long time. They had ground vehicles for a long time. They had radios for a long time, but they hadn't pulled it all together to see the synergistic effect of those things on each other. That's what's going on right now. You heard Earl talk about it, and you'll hear the Army talk about what they're doing, what they're looking for. That's what GM is very much invested in right now. The GM goals are zero congestion, zero crashes, and zero emissions, if you think about that. Just think about, forget the military for a second. Think about your daily life here in Austin, Texas, much less almost any other city in America or around the world. If you're talking zero crashes, zero emissions, zero congestion, what kind of a difference that makes? But what's the technology that can make that possible? That's where GM's invested. We're looking for a world that's more electric. We talked about that. That's more connected and has got the ability, more autonomous for vehicles, for products, to help think through the problem and take some of the cognitive load off of the operators so they can focus on other things. That technology is here today. Now, you see in the news the problems with the technology, but the bottom line is it's here, and it's only through use and experimentation and driving it, users having it, both in the civilian world and certainly in the military, that we're going to really amp up that learning curve and cause that technology to be something useful that takes us as has already been said, into the future. We talked a little bit about logistics. We can talk more in the dialogue and in your questions, but just think about alternate propulsion vehicles, whether it's electric or fuel cell vehicles, and what they can bring. Earl talked a little bit about silent drive. You guys have all been on or near a golf cart and see how quiet that is. Think about that in the military sense. I mean, in the civilian sense, we've got to add noisemakers to electric cars so they don't sneak up behind somebody or accidentally have it. In the military sense, lowering that acoustic signature is huge to success on the battlefield. Another is thermal signature. The thing that generates the heat in a traditional vehicle is that engine. And when you take that engine away and you use the electric drive, then you're driving that thermal signature way down. And in that, if you know that most targeting systems key on thermal signatures, then you made yourself much less targetable. And then back to something that Earl talked about, offboarding power, whether it's in a military sense or think about, I mean, all you gotta do is turn on the TV and look at a natural disaster. First thing that goes out is power. Right with that is communication. So think if the reaction forces coming in, the first responders, the National Guard, whomever, are bringing power with them on the very vehicles they're riding on, and what a difference that could make in reestablishing systems that bring capability back to the community and ultimately put it back on its feet until the larger systems can come back online. We talk about logistics just as a ballpark, because every vehicle is a little bit different. The average ICE or internal combustion vehicle has got about 165, 170 wearing parts, things that grind together by design. And we make the best in the world. There's another company, Ford, I think, that tries to, but that even when you do that, by design, those parts are wearing out the first time you start. You go to an electric vehicle, you go to an EV, you're down in the 30s. So just think about it from a military perspective, the number of parts that you have to anticipate replacing, those that you have to carry around the battlefield, the amount of trucking you have to tie up to do that is significant. We talk about fuel too, a little later in the discussion here. How much diesel, how much JP8 in military jargon are you going to have to bring forward if you're using a hybrid vehicle that has a diesel engine so it can generate power for the battery, but you only need enough fuel to generate power for the battery. It's the battery that's providing power to your sensors, power potentially for transportation, weapon systems, et cetera. In a practical civilian sense, we talk about offboarding power. The vast majority of vehicles that sit on a military installation do just that, sit. They don't put very many miles on them because they're moving in and around the installation doing the kinds of things you can expect. Moving supplies, moving parts, they've got security forces, things like that. But when they're sitting in a parking lot, in a motor pool, if you will, just think about it. You got a parking lot full of big, very significantly capable batteries. And if you wired those batteries together, you can buy power and recharge those batteries at the cheapest rate on any given day or week, and you can pull the power out of those batteries, that battery farm, if you will, to power the facilities there on post or just offset buying other power. So there's so many opportunities that come with this. General Motors is investing billions of dollars in battery factories and battery chemistries. Part of that is to make sure that GM has its share of control over those materials. We all know we live in a contested world. All you gotta do is turn on the TV, pick up a newspaper. GM wants to make sure, and American industry is moving this way, that they have access to the materials necessary for those current battery chemistries and the 3 and 4 that are already in development that'll succeed them. Because we have to have a reliable capability for the nation and for our nation's security. So I appreciate the opportunity to talk to you today. I'm looking forward to the questions and any questions that you might have.
Great, thank you. All right, so I get the easy job today. I get to just ask the questions, and so the first one I'm gonna direct to Colonel Bernier to start, and then anybody else can jump in. But you know, here at South by Southwest, lots of innovators, lots of startups. So Ken, if there's a young startup or an innovator out there who's working in the autonomous vehicle space, something along those lines, what would be a reason to partner with the Army? What would be the benefits of looking to partner with GVSC or DEFCOM?
So that's a great question, because I mean, it goes back to that wicked hard problem. And where I would challenge or offer is what we need is not an autonomy vehicle that rides on the road, because our commercial partners are really good at that. And we do that. We leverage the commercial market, batteries, which JD just talked about. We spend very little on batteries, but we talk a lot about specs and integration and how to utilize their capabilities. So that when we talk about autonomy, we're talking about really hard problems, such as, you know, let's go off-road. Let's unconstrained, uncontrolled environments, such as a fire in a house. You know, we have lots of opportunities that we want to do is to solve the hardest problems, to take people out of the equation and give an opportunity to give a robot to save other people's lives. So you know, if you wanted to participate and not think about the war fight, I think about how we can use it to save people, because that is what autonomy, when we look at, we focus on, is how do we lower the threat and lower tasks that we could have robots do over soldiers. Okay. So we'll start.
If I could just jump in real quick, I think it's a good question and a good answer, a good start to what we can talk about. I mean, there are so many different practical reasons why autonomous capabilities are important, and not the least of which is, look at some of the difficulties, and I say this, I'm not in uniform, some of the difficulties the military is having with recruiting, keeping the right numbers of soldiers in service, doing what we need to do. For every soldier that's tied up doing a task that an autonomous capability could relieve them of, that's a soldier, Marine, a sailor, airman, that could be doing something else that requires all those things that Americans bring to the service, besides just driving a truck or just operating a system. Commercial industry is investing heavily in autonomy, but the point was made, and a very good one, the military uses autonomy differently. And so there are companies out there that specialize in that difference, and industry is looking for the opportunity to team, partner, learn, and take advantage of those capabilities that are being developed, so we have a more complete solution. As you can imagine, GM's autonomy is mostly focused on getting you down the highway or getting you down the roads, and we do that exceptionally well, and we put a ton of money into it to get there, but we don't put as much money, or haven't, in the cross-country piece of it, and you have to have that marriage to really have a capability.
And I'd like to amplify that. First, I'll ask a question. Does anybody here know who Bridget Driscoll is? Ever heard of Bridget Driscoll? No, I didn't think so. So Bridget Driscoll is actually the first person to ever die in an automobile fatality accident. First one, first recorded one. And you think about that from horses to cars, and now as we talk about autonomy. So the number one opportunity for autonomy is safety, right? If we can prevent a Bridget Driscoll from happening, or a soldier or whatever, this idea that with autonomy we can drive safety. In fact, they recorded, there's an estimate that 92% of accidents are caused by human error on the road. 92%, right? So if you can take the human out of that, right, and create zero crashes, zero congestion, zero emissions, you can create a much safer world. And that's where, from a Cummins perspective, we're focused on safety and how we drive safety. And I think, as you were talking about there, so safety on highway and safety off highway, right? So if we can create a safer world for our soldiers to live, work, and operate, because I think the #1 job responsibility of leadership is to make sure we take care of soldiers, right? Making sure they're equipped well, trained well, and practice well, right? And those that are trained well, equipped well, and practice well, you know, I'm out of uniform as well, tend to come back from the battle. And so that's what we want, right? And so if we can create autonomous vehicles to increase the likelihood of a soldier making it home, that's where we should go. So if you are doing work in that space to increase safety on highway or off highway, and you're doing some amazing things, you can partner with companies such as us, industrial companies, partner with the military, partner to help us create a safer world that has actually 0 crashes. There's no more Bridget Driscolls, right? And there's soldiers that are coming home. That's amazing.
Yeah, great. Okay, now I'm coming for you.
Okay.
So you mentioned a number of things in the electrification area in your opening remark, and our other 2 panelists mentioned electrification as well. You know, big part of demand reduction. How do we get, you know, the thousands of fuel trucks that we've got running the roads right now? How do we reduce that demand for fuel? So, you know, your thoughts on what is feasible for electrification in the military sense, for our tracked vehicles, for our tactical wheeled vehicles. What's feasible in the near term, like in the next decade? And then what do you think is out there in the 2035 to 2040 space? And we'll start with you, Mr. Newsom, and we'll let others jump in.
Thank you for the question. I will say that Cummins is committed to the electrification. I'll just start off by saying we're committed to electrification. We've set up a new business unit called Accelera, which is focused on, the name even means, you know, accelerating to the new era of electrification. So we're committed to that.
Is that an acronym? Do we get to?
No,
okay.
Accelera. No, it's actually
Okay.
it's one of those words that sounds like an acronym, but it's actually a word. But we're also equally committed to investing in the U.S. And so we've actually launched and committed, and this is announced that we were going to jointly build a battery factory here in the U.S. So we're bringing battery manufacturing to the U.S. as well, kind of along with our partners. And so the focus on trying to bring electrification, you know, to the U.S. is real. But in light duty, there's an immediate application of electrification, and you can do that today in some light duty applications. And you know, my colleague here to the left talked about some of those light duty applications. But when you get to industrial applications and heavy duty applications, we're not there yet, right? And so battery density is not there. Battery chemistry technology is not yet there. And so when you look to do the trade-offs between the ability to move a vehicle and move a load over distance and in difficult terrains, you need lower emission ICE technology or lower emission combustion technology. And so what Cummins is doing is really working on that entire energy diversity spectrum. So we're going to use electrification. I talked about fossil-based fuels, so we're building, you know, lower emissions fossil-based fuel engines, much like we've done with ACE and many of the other things that we do in the marketplace. We're working on fuel cell engines, which will allow us to do fuel cell applications with hydrogen and other types of things. Even non-fossil-based fuels, biofuels, those kinds of things are going to be part of our fuel-agnostic engine platform that we've created in the industry. And then working on battery electric, as I mentioned, right? But we're trying to use the right technology in this decade, right, to solve today's problems. And so as you talk today, the answer is, you know, light duty, you can use electrification. Hybrid architectures are there today. So, you know, diesel and electrification together where we use the engine to charge the battery for those kinds of uses. So that's available today. And so those are the things we're working on, you know, deploying today. I think over the next 10 years, you're going to see a lot of experimentation. We kind of call it the decade of experimentation, where you're going to see different, you know, battery technologies, different fuel consumption technologies, different, you know, hydrogen technologies. In fact, there's H2 ICE, so you're looking at a way for doing hydrogen in an ICE engine, right? And so there's many of these kinds of technologies that Cummins is investing in over the next decade. And then I think through that decade of experimentation, probably in the next 10 years, we're going to find what solutions that are actually solving tomorrow's problems and can scale. right? So you need to be able to solve the problem, and you need to scale it, you know, to cover the fleet, you know, that the military has. And so the way I think about it, we're going to see that. And so that's the way I would describe it is, again, today is electrification for light duty, hybrid powertrains, you know, next 10 years experimentation on various different powertrain platforms and power platforms and fuel technologies, and then finding out what wins and then scaling that in 2035 and beyond.
Okay.
Yeah, I would just pick up on the fuel cell. I agree. When you for the military, if you're talking about a combat vehicle, an armored vehicle, or you're talking about a large truck, current technologies on batteries will weigh it out. In other words, you won't be able to carry the fuel and the supplies and the things that you want to, because you'll be consumed by just carrying the batteries. And there's a lot of effort going on right now to make the batteries smaller, more powerful, less expensive. But that's why I think fuel cells is such an important part of it. GM has been in the fuel cell business for over 60 years. We've powered various different cars with GVSC, which I can use that acronym now, and we've entered into some cooperative agreements with other companies to try to bring that technology in now, because the byproduct of a hydrogen fuel cell is water, potable water for that matter. And you can electrolyze any number of substances to create hydrogen. That's one of the biggest problems for the military. Okay, we just got to a single fuel, diesel. Now you're going to bring back yet another fuel that I've got to carry around the battlefield. I think the solution is hydrogen production at the point of need. How can you bring something that is portable, that is expeditionary, meaning you can get it there quickly, and generate hydrogen well forward in the battle space to allow you to fuel these hydrogen systems without having to have the additional trucks to bring it forward. I think that's the direction we're talking about innovation. That's where we're trying to push the envelope on that technology.
So second acronym for today, ROM, Refuel on the Move, which is, you know, one of our current TTPs. So, you know, fuel trucks set up at a location and a maneuver unit comes through, tops off. Do you envision, you know, the ROM of the future is vehicles are passing through and there's an electrification, you know, so it's a bad acronym, electrification on the move. EOM doesn't come off well, but along those lines.
Yeah, I do. So back to hydrogen fuel cells. The key is you got to have fast charging, right? When I talk to soldiers about the potential for electrification, okay, which tree am I supposed to plug into exactly, keep this thing running? Well, part of that is hybrid, right? Diesel hybrid. You're using the exceptional infrastructure that the military's invested in to move diesel around the battlefield to provide what's necessary to charge the battery. But for when you want fast charging, a hydrogen fuel cell can charge an electric vehicle and provide roughly 100 kilometers of range in 10 minutes. So back to the notion of a ROM, refuel on the move, you want to be sitting there getting either diesel or electricity the least amount of time you can, because you're potentially a target, right? Not to mention there's any number of vehicles behind you that need it. So about 10 minutes, you can get enough that unless you're completely depleted, you're probably back up to near full power and you can move on with your mission.
So to answer your question, I'll talk about now and the near future. So now, this is where, like, we try not to chuckle. We're going to do this thing called anti-idle. You know, with the car shut off? Yeah. Well, and
Cutting edge.
Cutting edge technology. But let's talk about that. We burn 70% of our fuel idling in that motor pool that I talked about. And so we're going to make them anti-idle. But we talk about the challenge of that. A lot of those vehicles are not designed that way. We're talking about non-electric and other vehicles that were simply just not designed that way. So some of it you got to reverse engineer back into the box, which is challenging. It's hard. And it's something that there's not a lot of profit in from a commercial perspective, but for us, it's everything. And then let's talk about the near term. So good partners with Cummins, and we did the ACE engine. That engine, like they talked about, 13% reduction. Well, when we did that, we took two challenges when we designed it, because we were the ones that designed it. We said, what's the hardest vehicle to squeeze it into? And that's what we designed it around. So we took it in a vehicle that right now, and I won't call out, but it's going to be around to the 2050s, 2070s. That platform is not going to change. And then it's reverse compatible across our fleet combat vehicles. So now we have an engine that is a fuel reduction that we can be able to introduce and go back and replace the engines we already have and create commonality that we don't have. The other part is we have two combat vehicles on the near-term horizon, XM30, which is the Bradley replacement program. Both of the offers that are coming on the street are both hybrid electric drives. So we see that. We're also doing an Abrams upgrade program. They call it the M1E3, hybrid electric. All of these are to try, in those particular groups, currently we're measured in gallons per mile. That's what we consume. Gallons of fuel per mile. So we see in the near term, which for us is early 30s, being able to deliver capability which consumes less fuel to be able to go further.
Okay. Let's pivot back to the whole idea of how would a startup or an innovator partner with the Army, and just talk a little bit about how accessible or inaccessible DOD can be. And so, Mr. Johnson, I'll go out to you. You've been on both sides of that. What's your sense of how well or poorly DOD is doing at making itself accessible to these incredible cutting-edge technologies that are out there?
So we'll start with, there's no bureaucracy like the military bureaucracy, and it's well entrenched, and it's founded on success. I mean, what got the military to where it is now, the Department of Defense and other agencies of the government, were tried and true processes. But those tried and true processes don't necessarily support where we are today and what needs to happen. And especially when you're trying to tap into entrepreneurs, small businesses that have a specific technology that they're trying to break in. So the department's done a lot of things to try to reach out to small businesses or to niche technologies, those owners of niche technology. One's called the Defense Innovation Unit. Originally was set up to reach out specifically to Silicon Valley. It just felt like we weren't, the military rather, wasn't getting access to those technologies, that brain power. But it's broadened its scope in a significant way. And now the Defense Innovation Unit, which looks not exclusively, but for non-traditional organizations, companies, and those technologies, has got an end user already. There's a thing called the valley of death. Many in this room might know it, where you spend a fortune on development, but it never goes to production. So it falls into this valley of death. Defense Innovation Unit is designed to bridge that because they've already got an end user in mind that helps put together what that need is. So you get the investment, you get the ability to bridge the valley of death. There's also mentor protege programs where a small business can work with a larger industry that has, all of the systems in place and all the people in place that at least pretends to understand how the department works and can help get through the process. We're set up to be able to do that, to mentor then a smaller company through that process, give them a leg up so that they can get their product to the right place at the right time to influence and at least have a shot at getting the military a chance to look at that technology. The nation has changed how it contracts. There's other transitional authorities now, there's middle tier authorities or pathways that has greatly streamlined the way in which the government can go after technologies. And so I think the government's doing a lot. I think there's a lot they could do at the speed of need that we need in current era of competition. But those are some of the ways. SBIR, Small Business Innovation Research, is another one where a small business could come in and compete for something very discrete and then have that potentially picked up. And so those are means that small businesses should be aware of, think about, and then spend time talking to bigger industry, okay? Spend some time talking to Cummins about how to negotiate, how to navigate those systems.
Yeah, I would like to add on to that. I think that's a fantastic way to think about it, and think about ways that small businesses can actually contribute, kind of to the military enterprise, and I'll use that word. And as I think about it, and I think about areas where, groups that are interested in doing that can actually make a difference. And you talked a bit about this with the infrastructure challenge, right? There's an on-highway infrastructure challenge. That's part of the challenge with electrification. That there was an example that was done actually at the Port of LA, and somebody was trying to test an electric truck, and they realized that the electric truck took half the payload, only could do one trip per day, than a normal diesel truck. And so you can't be effective at half the payload, one trip a day. That doesn't work. In fact, they named it the one-trip truck, right? So that's not useful, right? And so think about the one-trip tank. So I think the idea here is if we can find creative ways to solve the infrastructure challenge, solve the weight load challenge, and hydrogen is a great way to solve the infrastructure challenge, move hydrogen out, mobily, and find ways to use hydrogen to power batteries, or to power fuel cells, or actually hydrogen to electrical is actually a pretty efficient way of moving power. It's actually more efficient than other means of doing it. And so if you're interested and have that kind of capability, there's ways of solving our infrastructure problem for both on-highway and off-highway with this kind of technology. So, those are ways that I think organizations can actually help to contribute to solve this problem.
We'll let our acquisition officer get the last word on this question.
I'll be really simple and to the point. In this particular area, and I'll pile on other transactional authorities, that's special authorities that we were given by Congress a few years back. For a small business, it is a superpower tool. And if you're interested, I will connect you to the one that we have in Detroit, where we do most all of our small innovation type stuff. And this is how powerful it is. We got about a 5-year contract with over currently 750 members. It's very easy to join as another member, and its power is anything else not covered in this OTA. And I like to use those words because that means we do a lot of things, but it can also do anything else not covered. And so when we look to that, it is very simple problem statements and then what we're trying to solve and we get after. And we do this annually and biannually where we're trying to solve problems. So if you're interested, afterwards, you just give me your contact information and I will put you in contact with the lead for that group because we'd love to partner with you.
Okay. I'm going to ask one more question, and then we'll open it up to the audience. But going back to the idea of how do we reduce that logistics tail, right? We're all watching the news and seeing that the operating environment already, and more so in the future, it's a transparent battlefield. If you can be seen, you can be targeted. If you can be targeted, you can be killed. And so how do we reduce the number of logistics assets that are out there able to be targeted? And so I think I'll come back to Mr. Newsom and ask about the work that you referenced on advanced powertrain development. How can some of that work contribute to reducing the logistics tail?
I think that's a great question, and thank you for that. I love the concept of the transparent battlefield and how can our powertrains contribute to creating, a transparent, silent sort of battlefield. And I think that's, where we think we can really provide some amazing capabilities of, by leveraging some of our commercial powertrain capability into the battlefield and building these integrated, connected powertrains, as I talked about, the automated, kind of connected, energy diverse powertrains. And if we can add digital features to that, we can aim to lower the overall total cost of ownership. We can focus on providing things like predictive maintenance, do digital twinning, kind of making sure the network is optimized. And so I think, as to try to create lower the amount of assets that are needed to operate in the battlefield. If we can get digital capabilities into those assets and get much better predictable nature of them, make sure that the supply network is optimized, reduce duplication, unnecessary efforts, optimize the distribution and consumption of power through that ACE world that I'm talking about, we can lead to a much more transparent battlefield, much less assets on the battlefield that can be seen as either targets or targets of opportunity, and much more efficient assets. Yeah. And so the combination of an intelligent powertrain will help us to deliver those kinds of benefits to the battlefield.
I just pile on here because I think that's a really important part of it. We can talk about how you introduce different fuels in the battlefield and how you can take trucks off and you can use automation in lieu of people to move either resources forward or back as needed. But when I first spoke, I talked about, back in the 30s and 40s, that one of the things that really changed the way ground mobility was used were radios. Well, now you have the proliferation of and means of gathering data, looking at data. You can, to the point that Earl was making, get after a level of predictive analytics for maintenance that drives who needs the supply, who needs maintenance, what has to be done. Right now, and I stand to be corrected by the uniformed people on the stage, for the most part, we're expecting a 17, 18, 19-year-old soldier or Marine to go take a look at the vehicle and say, here's what the problem is.
That's right.
That's right.
We've been there since back in the 30s and 40s, okay? Whereas
I wasn't there in the 30s and 40s.
Systems, I said we. No. But there are systems out there today that do that. If many auto manufacturers have this. For GM, it's called OnStar. GM OnStar will tell me right now today, my car sitting back home, what the tire pressure is, what the oil pressure is. Whatever sensing I want to put on that vehicle, it will tell me about it. There is no need today. By the way, I can roll it up. I can see it for a vehicle. I can see it for a whole fleet or for a whole organization. OnStar system moves more data in any one day, and it's more cyber secure than MasterCard and Visa put together. That's what's going on out there. The military can and will tap into that so that you're not reliant on a young soldier to feed that information, which thereby feeds the logistics chain. Right. You're allowing the smart equipment to do that for you and tighten up, sharpen up what we're trying to move around, so we're not having to just anticipate or send plenty in the hopes that you're going to hit the right target with whatever you're trying to move around.
I think it's interesting, for several years we've been talking about improving the speed at which we move information from the sensor to the shooter, right? So that we can more quickly respond. But for the last 2 years at least, we've been talking about sensor to shooter to sustainer, right? So as soon as that shooter does something, the round that was fired is automatically calculated back at the sustainer. The wear and tear on the parts associated with that are relayed to the maintainer as well. And so sensor to shooter to sustainer, if we can speed that chain of data flow, we'll be moving in the right direction. So, okay, I think at this point there are microphones in the front and in the back, and we'll open it up to any questions from the audience. Sure. That's your walk-up music. That's right.
Hello, I'm Paty. I'm from Brazil. I work at Embraer, and this is an acronym for Aerospace Brazilian Industry. And I have a doubt, actually. You talked about autonomous, and we are also working on it. And we know that there is a challenge of acceptance of the users and also the ones who develop autonomous solution, because we are used to work with non-autonomous one. As this is a challenge, and for me it is a culture challenge also, I would like to know if inside the Army you are working on it with some culture aspect for your people to understand more about autonomous and to accept this better, like pilots, for example. And I would like for you to, if for your customers, you are thinking about this kind of development, of culture development for them to create this acceptance. Thank you.
Great question. So I'll quickly answer that from the perspective of, and please feel free to, stand, sit, we'll play your music again, whatever makes you comfortable. But so I'm the commandant of our transportation school. So I train all of our truck drivers, and we're absolutely using that exact phrase, a culture of autonomy, getting leaders comfortable with the idea of autonomous assets and capabilities. We're trying to integrate that into our training very early on, from our operators all the way up to the leaders. What we've noticed in our experimentation with the autonomous tactical vehicle system that we're working on right now is that it's pretty easy to build confidence and acceptance of the operator once he or she spends time around the system and sees that it works. It's the leaders who have to trust that they're going to be able to employ that in the right way. They're going to get things through. It's going to just take repetition and successful repetition, I think, to begin to change that culture. But that exact phrase is absolutely part of our lexicon right now. So,
Ma'am, you said it great. A lot of it has to do with the generational. I'd say the younger generation, they're very comfortable with it. They accept it. But as the leaders who underwrite their risk, and we worry about all those things that it might do or might not do, and then those are our concerns. So, ma'am, you put it best. We have to overcome it as an institution, because it's not the operators, it's the risk writers that are concerned.
yeah, absolutely. Gentlemen, comments on that?
Yeah, I would say it because there's 4 or 5 different levels of autonomy depending on who you're reading, but the L1, L5, and I think there's more comfort as you move up the levels of autonomy. You get more and more challenges from a comfort perspective, and I think from now at this moment, I think the answer is to try to drive comfort and trust, because that's really what you're getting at, trust. A human has to be in the loop, right? That's, that's why when you're in your vehicle and it's doing autonomous driving, you have to grab the wheel every once in a while, right? And so, I think the idea is that as long as we can keep a human in the loop at the moment, we can drive a little bit more comfort in autonomous vehicles. And so as Cummins, we're thinking about things about driving different levels of autonomy, and we have a research group that's looking at it. And so like platooning, so you'll have one truck that's in front, and then the other trucks will follow it, right? And so you still have the human in the loop, but you have but the trucks are following and they're creating a platoon, so you can get the efficiency going. And so that's things that we've looked at. I think full autonomy, it's going to come, whether it's on highway or off highway. I just think as we work to build the algorithms up, those kinds of things, we can begin to get the trust going. But it's going to take a journey.
Yeah, I think it's pretty much been said. It's all about confidence and trust. One of the things we do with our customers when we're going to show military equipment, we'll put them in a Cadillac Escalade, which has got SuperCrews. Put them in the driver's seat, take them down the highway, click the thing on, and they're okay if they're like this. But as soon as you say, "Look at me," that's terrifying. And so I think he's right. The younger generation will pick this up much more quickly because they're digital natives. They'll grow up with it. But I think the proof points. So the other thing I would say is, if it's a completely independent autonomous thing, that's going to be easier. It's when it's autonomous, but there are people in it, and you're expecting that machine to operate around you, that's tougher.
Great.
Hi, my name is Sarah. I'm local to here to the event. I'm representing a company called ARSAM that develops custom AR and VR for training for equipment handling and repair and whatnot. My question is, I just learned in a different session that the DOE and DOT are collaborating together for developing the infrastructure for EV charging. And along those lines, obviously, I have supported a company that developed a 3D printed blower that's optimized for solid oxide fuel cells. And they were originally funded for a cyber or CIVR, whatever you want to call it, to move up that technology up in the TRL scale. And they got so far and they didn't get funded, but it's a really good technology. I'm just kind of wondering, are you guys going to be collaborating with DOE and DOT in their joint whatever force? And when a technology, if that's one question, and the second question is, when a technology is funded by one agency and they don't re-up their investment, do you guys even look at the portfolio of companies that are available, that have received money? Because if you guys want to have EV, military vehicles, I mean, you're going to need to have portable EV charging equipment. And so this type of thing that I have, or that I have supported, is something that'd be valuable. And it's frustrating to me as a mentor or a consultant that I know that, the money dried up for that specific company. Those are my questions.
Okay, great. I'll open it up to anybody who's aware of the DOE, DOT partnership.
Well, I would just say, so we've kind of focused on Department of Defense in here just by the nature of this, but, and I'm sure Cummins is like this as well. We're focused across all the government agencies. So we're working with Department of Energy in particular on some projects. That's the first question. The second question about, okay, so what happens when you develop this capability and it falls off a cliff? That's kind of, in some cases, it can be that valley of death I talked about, where you had a very good capability, you just couldn't get connected to an end user. This is where you need to connect to the industry that's in the business and explain to them what you're bringing, and you may find out, if it's better, cheaper, et cetera, that there's a very willing audience there for you that potentially would look to work with.
And I'll double down on that as an industry representative on this panel, is that absolutely we work like DOD Focus here, but DOE, DOT, all of the alphabet agencies, right? We work with, and I would tell you that charging infrastructure is something we're very interested in. Because as I talked about the infrastructure challenge that's out there, that's both on highway and off highway, charging infrastructure is one of those big ones. As I talked about that one-trip truck kind of thing, the other thing that was happening is that this organization said they needed 135 trucks, right? The local utility said, well, you could only have 80. And he said, okay, that's not really going to work. I need 135. And so charging infrastructure and creative ideas on how to solve the infrastructure challenge, that's going to be one of the biggest challenges to driving electrification further in the U.S. And it's going to take a public, private, government, kind of combination to make it all work.
Okay, you can hear the noise from the bar starting to pick up, which is our sign that we're getting close to the end. We've got time for one last question, and we'll answer it rapid fire, so go ahead.
Thanks, I'll be brief. My name's Doug Priest. I'm with Microsoft. I'm the public transportation lead in our government organization. My interest and question is, from a military standpoint, you're obviously doing a lot of innovation in the technology space. What are some of the technologies that those of us working in the civilian public transportation space should be paying attention to that maybe we haven't been paying close enough attention to so far?
Yeah, great question. Ooh, I know, right? Are we ahead on anything?
So that's a great question, and I'm getting a little stumped here, so I'm gonna have to think about it, but I'm not gonna give up on that. There is stuff that we are directly engaged in, but sometimes, at least from a technology standpoint, it's always on the periphery. And I'll just talk about a default to human-machine integration, because we're working really hard, and it's one of our biggest efforts. And if you hear General Rainey talk tomorrow, he'll be talking about that. And that's really about that partnering and controlling. And what we're trying to do in real time is control robots on the battlefield, multiple. Because our vision is not right now, which is, one user, one robot. I want to have one user and 20 robots. And we are pushing very hard to do that, to be able to give them taskings, to be able to use autonomy and AI learning to be able to accomplish that task. And it is one of our biggest priorities to get back to, because it goes back to how do we, make users safer? How do we make the warfighter safer? And the more that we can do with robots and then figure out that integration work, we will be successful.
I will just testify. I have a 16-year-old son, and anytime I talk about, I come back from a deployment or a training exercise and I talk about the challenges, he usually just looks at me and says, "Don't you have robots for that?" Right? So I tell him we're trying. We're trying to get there. Hey, thank you all again for attending. If you could, a round of applause for our panelists.